In this video, what we're going to focus on is how to rationalize the denominator. Basically, what that means is that we are going to try to remove any radicals in our denominator. So for instance, if I have something that looks like this, 1 over root 2, I want to get rid of the radical, okay? So how do we do that? So if I start 1 over root 2, what I'm trying to do is I'm trying to get this to be a perfect square. Well, in order for it to be a perfect square, I need this to become a 4, because 2 times 2 will give me 4. So what I'm going to do is I'm going to multiply the top and bottom by the root 2. Because as long as I multiply by a fraction of 1, right, it's not going to change my value. So again, multiplying my numerator and numerator together will give me a radical of 2 on top. And then the bottom, the 2 and the 2 can be multiplied together, leaving you with the radical of 4. Radical of 4 will give you 2. Right? And I could double check that with my trusty calculator, right? So we can see, let's clear all of that. So 1 over the radical of 2 gives us that decimal point 707. And then the same thing, radical of 2. Make sure that the divide sign is on the outside, so right like that, 2, and we'll get the same value. The whole reason why we rationalize the denominator is that it's easier to divide something by a whole number than by an a irrational number, so to speak. Okay, so let's try a couple other ones, right? So how about if I say 3 over radical 10, right? So I'm going to go ahead and I'm going to multiply radical 10 by radical 10 to the top and bottom, again, fraction of 1. 3 times root 10, since this 3 does not have a radical over it, I keep it on the outside, and then this will give me the radical of 100, which ultimately gives me 3 root 10 all over 10. We also want to make sure that we can simplify our radicals, so we've been focusing on that. And so 10 is made up of, radical of 10 is made up of radical of 5 times radical of 2. These are prime numbers, so there's no perfect square in them, so there's nothing else we can do. So this is as far as we can go. We always want to see if we can kind of simplify our problem. All right, let's try a few more. So why don't you go ahead and try these two problems on your own, and see if you get the same result. So let's do 4 over radical 5 as our first one. And then here's a little trickier one. How about root 2 over root 3? So go ahead, pause the video, and when you come back to it, we'll walk through step by step. All right, so if you're coming back from unpausing the video, so the first one, radical 5 is not a perfect square, so let's go ahead and multiply top and bottom by the radical of 5. So 4 times root 5 gives you 4 root 5. 5 times 5 gives you 25, and ultimately it gives you 4 root 5 over 5. Don't know why there's this extra little piece right there. So that's what we should have gotten for our first answer. If you want to kind of skip this step and jump straight to that step, perfectly fine. All right, number 2, there are 2 radicals on this problem, so that's why it's a little trickier. So I'm still going to multiply top and bottom by root 3, and I'm going to get a root 6 over root 9, which ultimately gives me root 6 over 3. So again, that is my answer. 6 cannot be broken down because 6 is just made of 2 and 3. And again, so we can multiply them together since they're under the same radical. Now, what happens if we get something that possibly looks like this? So if I say 2 over root 20, right? The first thing that you would do is you would multiply root 20 onto the top and on the bottom. And so if I did that, I'm going to get 2 root 20. And then 20 times 20, we know it's just going to be the square root of 20 times the square root of 20 is just going to give us 20 all together. Okay, I would simplify this fraction, leaving you with root 20 over 10, and then I have to simplify root 20. So root 20 is really made up of root 4 times root 5 all over 10, which ultimately is 2 root 5 all over 10. Ooh, and we can still simplify. 2 goes into 10 5 times, so root 5 over 5. Look how many steps it took, especially if I right away just multiply by that radical of 20. So I'm going to do it again. So a do-over. So instead of right away multiplying radical of 20 to the top and bottom, I'm going to break up radical of 20. So I'm going to break it up into 2 over root 4 times root 5, which ultimately gives you 2 over 2 root 5. I can simplify my fractions. So in reality, I have 1 over root 5. And now I can multiply top and bottom by root 5 over root 5, which ultimately gives me root 5 over 5. So again, if you want to simplify at the very beginning, sometimes it's a little bit easier. If we want to simplify at the end, that's fine. We're still going to end up with the same result. So let's pick a couple more problems, and let's try them on your own. So let's do, how about 3, so try on your own, 3 over the radical of 50, so try that one. And how about 4 over the radical of 12? So go ahead, pause the video, try these two problems on your own for rationalizing our denominator. All right, coming back. So we can solve these problems 2 different ways. So ultimately we're going to get the same answer. So what happens if you just multiplied root 50 by root 50? So ultimately you're going to get 3 root 50 over 50. And the 50, 3 and the 50 don't cancel out. But I do know that radical 50 is really radical 2 times radical 25. So this is really 3 root 25 times root 2 all over 50, which is 3 times 5 times root 2 all over 50. And the 5 will cancel away with that 50, leaving you with 10. So ultimately, this is 3 root 2 all over 10. So that's that problem. All right, we'll hold off on this one. Let's do it one more time. So I'll do it in green. So 3 over root 50. So what happens if we simplified root 50? So we said 3 over root 25 times root 2. So 3 over 5 root 2. Now I'm just going to multiply top and bottom by root 2 over 2. Back to green. So this will become 3 root 2, 5 times 2, which ultimately gives me the same answer as 3 root 2 all over 10. Again, I find it easier to simplify at the very beginning. All right. So let's try the second one. I'm going to do it on a separate page. So it's 4 over root 12. So 4 over root 12. So let's simplify root 12. So root 12 is really made up of radical of 4 times the radical of 3, which ultimately will be 2 root 3. The 2 and the 4 simplify first, leaving with 2 over root 3. I'll multiply top and bottom by the fraction of 1. So ultimately I will get 2 root 3 all over 3. Nothing can simplify out. That is our answer. If we did it a separate way, right? So 4 over root 12. So right away I multiply top and bottom by root 12 over root 12. Oops, green. This will give me 4 root 12 all over 12. 4 goes into 12 3 times. So I get a 3, but I'd still want to simplify this to 4 times 3, both under the radicals, which ultimately gives you 2 root 3 all over 3. So again, notice that we get the same results either way. So again, rationalizing the denominator just means that we're moving the radical out of our denominator. So let's go ahead, let's write that down. So rationalizing the denominator is removing the radical from the denominator. Right? So that's all that rationalizing the denominator is all about. Make sure I spelled that right.